So following on from the previous video, we got to this stage here. Okay, we were trying to sketch this graph here. So we've got one block multiplying with another block here, and so as x tends towards infinity, then this also tends towards infinity, and as x tends towards negative infinity, our graph here tends towards positive infinity. The next thing to do here is try and establish where this graph crosses the y-axis and the x-axis. So they're quite easy to find out. If you put 0 into the x here, and then put 0 into the x here, then this thing here will be 0, because 0, if you put 0 into the x here, then overall this thing will be 0. So if you put 0 into the x here, then y will be 0, meaning that it must cross right at the origin. Okay, and then if you try and put the number 3 into here, then this thing here will be 0, and then 0 times whatever this is, then it will be 0. So the point here is that when you put 3 into here, then the whole thing here will be 0. So we know our graph must cross at the origin and must cross here. So the next thing to do here is to look at the derivative of this. Look for the critical points. So let's differentiate this now. So if you start out with our original graph here. So we've got this thing multiplying with this thing here. Now let's try and differentiate it. So multiply this out. That will then give you this. Differentiate it. It will then give you this. Okay, and then strange as it may seem, you can actually factorize this. Okay, so look at this. What's in common with this and this is actually what's in common here is, well, you probably have to pause the video here and really think about this. Looking at this here, you can actually factorize it. It does actually factorize to this. Okay, so looking at this, take this out as a common factor, and then when you look at this, you've got this thing times -1. That will then give you this. Well, anyway, looking at this, it is possible to factorize this. Okay, so another example here is that if I give you something weird like this. So this here is quite similar to this. I'm just trying to show to you that it is possible to factorize this. Okay, so you've got something weird here, something weird here. You can factorize. Here's another example. Something weird here, something weird here. It is possible to factorize it to this. Okay. So when you get to this stage here, hang on. So you've got your y equals blah blah. Differentiate it. It will then give you this. The point that I'm trying to make is once you've differentiated it, try and find out what values of x will make y prime equals to 0. So you're trying to find turning points or critical points. So set the y prime to be 0. Okay. So hang on, start again. Our y equals this. Differentiate it. Blah blah. It will take you to here. Okay. And then from here. Hang on. From here. So that's from here. Tidy this up. So blah blah blah. Tidy up, and it would take you to this stage here. So try and find out when this thing here will be 0. Try and find out when this thing here will have a gradient of 0. Okay. So if you look at this, imagine this as being a bubble here, multiply both sides by the bottom bubble here, so that will get killed off. So it really boils down to when will this be 0? Well, this thing here, the numerator will be 0 when you put a half into here. So when you put x equals a half into this thing here, then this thing here will be 0. Okay, and then 0 times 3 will be 0. The point here is that you've got to set this to be 0. So find out when the gradient will be 0. So when you put a half into there, then the gradient will be 0. So what we've got so far is that the gradient, or when you put well, we know that somewhere along here the gradient will be 0. Okay, so yeah, somewhere along here something weird happens at x equals a half, And looking back at this, oh, something else happens when x equals 0 as well. Because if you look at the derivative here, hang on. If you look, so this is our derivative. This is also our derivative here. When we are trying to find out when our derivative will be 0. So here you've got one block multiplying with another block here. If you put a half into here, then of course this block here will be 0. 0 times whatever over here will be 0. Now, hang on. Looking at this again as one block multiplying with another block here. So when would this be 0? Well, if you put 0 into here, it's okay, looking at this here. So here you've got x to the power minus 4 over 5. We don't understand what it means to have a power of a negative number, so we will immediately jump to 1 over x to the power 4 over 5. Okay. Now when you put 0 into here, 0 to the power of 4 over 5 is actually 0. So this whole thing here will be 0. So now you've got 1 divided by 0. So it's undefined. It breaks down. So all that we know is that something weird happens when you put 0 into this whole thing here. Okay. So going back to our graph, when we put a half into the function, nothing actually breaks down. It's legitimate. But when you put 0 into our derivative, then this thing here will break down. So all that we know so far is that something weird happens when you put 0. Something weird happens at x equals 0. But something legitimate happens when you put a half, when x equals a half. So all we know is that something happens at x equals a half, and something weird happens at x equals 0 here, because our derivative breaks down. I will continue in the next video. So this is our graph so far. So we know something's happening at x equals a half, and we know something weird is happening at x equals 0. Okay?